Okay, let's go ahead and wrap up for one with just a few final thoughts. So we start talking about um, looking to see if there's a relationship between two variables. And one thing we need to keep in mind is that we cannot conclude that two correlated variables have some type of causal relationship when we're looking at observational data. Okay, we can't do it. And it kind of comes back to this idea of this lurking variable. Okay, when we talk about observational data, and we want to be able to say, well, these two correlated variables have some type of cause and effect relationship. It just doesn't work that way. They give this silly example to kind of illustrate it. Like they say, for instance, if we say air conditioning bills, as those increase, then so does crime rate. So that seems silly because we're not really able to say, okay, well, because this is the case, maybe we should all just turn off our air conditioners so that crime can decrease. I mean, this is just silly. It's not the case. But the idea of this lurking variable is clearly the reason the air bill is increasing is because the air temperature, right? And then maybe a result of the air temperature being warmer is why more people go out and commit crime. I'm not real sure why this example was chosen. I think it's pretty silly myself. But the point to really drive home here is that there is some other cause, like a lurking variable, that would be the reason. And with observational studies, those lurking variables don't allow us to make a conclusion as to correlation, having some causation between two variables. Here's a better example, other than air conditioning and crime. Let's look at this study that was done. I shouldn't say study, but let's look at this data that's presented to us on cola consumption. And they're looking at how this is associated with a lower bone mineral density in women. So the data provided is from 15 women, and it looked at their bone mineral density in relation to consuming sodas in a week. So for our X, we have the number of colas per week that are consumed. And for our Y, we have the bone mineral density. So we can look at a scatter diagram here in a second of this data, but they did find R, and they found R to be this negative 0.806. So without using the critical value table, I would go ahead and say that that seems strong enough. That's just me. I'm happy with a 0.8. All right. I would say that's a pretty strong, well, I'd say that's a moderate. I'm going to go with moderate. Moderate, negative. Let's get rid of this rainbow bright here. Got moderate, negative, linear association or relation. But let's go see what the table has to say. So if we go back to our critical value table, we know we have to take the absolute value of this, which is just going to give us this 0.806. So what's the critical value say for a sample size of 15? Well, it says that we just need to be larger than this 0.514, which we clearly are. So we can just confirm what we already felt confident in, is that yes, there is this moderate negative linear association. Now, stating moderate, strong, somewhat, I mean, that's kind of on you. That's something I always have done, is stated the degree to which I feel it's linear. But you don't have to say this. You can just say, yes, there's a linear relation. And here's the graph. Here's a scatter plot. I'm going to go ahead and just try to draw a line right down the center there. And yeah, it seems like most of these plots follow this linear trend. Oh, excuse me while I yawn. Keep in mind that we don't need all these points to fall on this line. Okay, we're looking for a trend here. We're not looking that every one of them is sitting on top of this line. But what we don't want to see, remember again, is something like this scattering of plots. We don't want to see something that kind of goes like this, right? Because that's just not linear. But this looks good. So the reason behind this is we were talking about lurking variables. What's wrong with this study, right? What's wrong with our data is, are we able to say, well, I had a pretty good R. Forget what it was. I'm just going to go 0.8 something. That was pretty nice. So therefore, I can go ahead and conclude that yes, the number of colas consumed can decrease bone mineral density. Or do we need to point out these lurking variables? Because this isn't an experiment, it's just an observational study. And think about all the other things that could affect the bone mineral density in these 15 women. Age, body mass index, height, smoking, the list goes on and on. So with our observational studies, we have to be careful because we cannot conclude that the correlation between two variables has some type of causation. So we cannot conclude that the correlation that was seen indicates some type of causation. Meaning colas cause lower bone mineral density. And that comes back to the fact that this was strictly an observational study. All right. So that wraps up 4.1.